Hi everyone, you can see this is the 4 probe which is used to find out the resistivity of a given semiconductor. So aim of the experiment is to find out the resistivity of the germanium sample with different temperatures, and also to calculate the activation energy by using this method, 4 probe method. The apparatus required for this experiment are 4 probe and the germanium sample which is kept between these 4 probes and the base. Next we require the 4 probe setup, and also we require the variac to vary the temperature and digital temperature indicator. So first we have to make the connections with the help of connecting wires. So we have to connect the above 4 terminals. As we can see, the chamber including the germanium sample, where here the sample has been kept between the 4 probe and the mica sheet. So above 4 terminals on this germanium sample containing setup, we have to connect it to the 4 probe setup, where we can see here the 4 terminals. So 2 terminals across current and 2 terminal across voltage we have to connect the chamber that including the germanium sample. And next we have to connect the variac to the side terminals of this chamber containing germanium sample, and then from variac to the temperature indicator we have to connect using the connecting wires. So resistance of the conductor is given by this formula. So resistance is equal to rho into length by area. So rho is the resistivity of the conductor, L is the length, and A is the area of the conductor. Unit of the resistivity is ohm meter. So resistivity also measured in terms of voltage and current ratio. We can multiply with 2 pi into S, where V is the potential difference between inner probe in volt and I is the current through outer pair of probe in ampere. So we have the experimental kit, that is the 4 probe setup, where we come across 2 probes for voltage and 2 probes for current. That's why we call that as a 4 probe method. Rho is the distance between, S is the distance between any 2 connecting probes. Formula to calculate activation energy. Once we plot the graph of log rho versus temperature 10 to the power 3 divided by capital T, that is per Kelvin. So from the slope of the graph, the activation energy we can calculate. We should note down the observation before starting the experiment. Sample used germanium sample, which is a semiconducting material. Distance between 2 connecting probes 0.9. Here is the block diagram for the 4 probe. So if you see, these are the 4 probes. The distance between them is 0.9 centimeter. Constant current supply we have to give, that is 4 milliampere. Thickness of the sample 0.05 centimeter. These are the required parameters for the calculation. We should write in observation. So this is the block diagram for making the connections for this experiment. So 4 probes, 2 terminals across current and 2 terminals across voltage, and the side 2 terminals across variac to note down the temperature in the temperature indicator. Tabular column for this experiment. Temperature you should note down from the temperature indicator, digital temperature indicator in degree Celsius. Corresponding voltage from the 4 probe setup, and the resistivity you can calculate using this formula 2 pi S into V by I, and log rho you have to take, log of the resistivity you have to take, and the temperature you have to convert in terms of Kelvin. You have to add this 55 to the 273, you will get 328 Kelvin. Like that you should convert in terms of Kelvin. Then take the ratio 1 by T. If you calculate 1 divided by T, you will get the power 10 to the power 3 by 3 per Kelvin. So calculate last column, that is ratio of temperature. Then go for the LSF method. For LSF method, you have to select here the temperature, last column, and the resistivity. Consider it as Xi temperature and log rho as Yi, and use the LSF method, Xi square Xi Yi. Calculate the LSF parameters, and then calculate the slope using these LSF parameters P, Q, Rs. Then you will get the slope, that is theoretical, and then you can calculate intercept using this formula. Next you can calculate activation energy theoretically and graphically. So first you have to plot the graph here, graph of temperature versus log of resistivity. So once you plot the graph, you will get almost a straight line. Take the slope of that. So the slope obtained here is 1.63, and calculate activation energy using the formula, that is 0.1985 into slope. So here from LSF method the slope is 1.59. Use this formula and calculate activation energy theoretically, that is 0.3 electron volt nearly. And here the activation energy you can calculate from the slope of graph, 1.63 into this value. So it is also nearly 0.3 electron volt. Then at the end you can write the result here. Variation of resistivity of a given germanium sample with the temperature is linear, and the activation energy of the germanium sample theoretically and graphically both are near, about 0.3 electron volt.